once we have an amplifier done, we take it over here to the end of the bench and set it up so we can listen to it while we work. That way, if it decides to misbehave or doesn't sound quite right, it's still right in here where we can take care of it. First thing that I want to do when I get it on the end of the bench here is listen to it on some music and watch it on the scope. After I've listened to the music and I feel like it sounded good, which I did, then I want to look at a sine wave on here. That way I can begin to get a sense of what kind of power and how clean the amp is and the channel balance and stuff like that. Of course, just because the sine waves look the same doesn't mean that the channels are actually balanced. It's harder to see it on the scope than it is on a meter. So down here we actually measure the power. We'll just bring the sine wave up until it starts to clip. See, we hit 5 watts, 6 watts with a clean sine wave. So as long as these are both telling me the same thing, I know the amp is good, I know both tubes are good. And that's what I'm interested in finding out at this point. Alright, once I've listened to music on it and everything looks and sounds good, then I want to see a sine wave up here on the scope. I've got the right channel on the top, the left channel on the bottom. Right now I'm just looking to see that they're both the same. And they do look pretty nicely balanced. Now the next step is to look at the clipping, which is really the most important part. We're going to put the amp into duress, for lack of a better term, and see how it behaves. Now, we can throw that into a dummy load so we don't have to listen to it. But I wanted you to hear what that sounds like when an amp clips on a sine wave. As you can see, it's much different into a dummy load than it is into a pair of loudspeakers. That's very important to understand. A lot of engineers will look at this and think that this is what the amp sounds like when it clips, but in reality, the inductance of the loudspeaker makes the amp behave completely different. Okay, so you saw the amplifier clipping into a dummy load. Then you saw it get ugly when we clipped it into a loudspeaker. So you would think that the way it behaves when it's clipping into a loudspeaker is more telling of how it sounds, which I suppose it is, but that's still not the clipping that your ears are going to hear when the amp clips. So what we've done is we've taken this listening device, which is picking up the sound in the room, which when I quit talking and turn this up is going to be the sound of the loudspeaker. And I want you to compare this wave, or these two waves, with these two waves, and watch when I clip them, and look at how differently they clip. In other words, watch how the loudspeaker interprets the clip and what it does with it, because that is what we hear. That is the clipping characteristic of the amplifier. Okay, here we go. Let me put it back on speakers. When it's working, it looks deceptively simple. But the truth is, this is going to show me if there's any channel imbalances. It's going to show me if the two tubes are drawing the same amount of current. It's going to show me whether there's any distortion that shouldn't be there. Oscillations will make the sine wave fuzzy or start to jiggle or dance when it should be, flat and smooth like this. And the longer you keep it on here, the more likely you are to see a problem, because problems don't always happen immediately. Sometimes they're generated by things warming up, tubes in particular. There's been several times when we've had output tubes on here and we set it up into a clipping state like this, which it's putting out a lot more power than it's rated. When it's clipping, of course, it's useless because it's just distortion, but nevertheless, it creates a lot of stress on the amplifier and on the tubes, and this will weed out weak tubes in a hurry. What you'll see is when one tube fails, let me just show you here. If we are testing a push-pull amp and one of the tubes fail in the push-pull pair, you'll see either the top half or the bottom half of the sine wave just literally disappear. And that's a pretty telling indicator that the tube's not going to make it. And that's when it's, at maximum volume. You turn the volume back down and put regular music on it, the tube may start to work again. And this is the kind of a thing that you cannot find on a tube tester. I don't care how good it is. I know because I have the very best tube testers in the world. You cannot find this problem. This is the only way that you're going to find the problem with a bad tube. The kind of problem with the tube that's going to only show up when you're cranking the music. And it's going to make you absolutely certain that there's something wrong with the amp when in fact there's not. So that said, that's the basic test, and what we do for the rest of the period is we listen to it, just use it for the shop radio. And build more amps.